Okay, so today we're moving on. We're still looking at matrices, but now we're going to look at a different sort of application of matrices, meaning, how we can use it in some like real world scenarios. So we are now going to use it for what we call communication networks. So we can set up some matrices to display, because it's always like a way to display data. And obviously, you're gonna see how we can use it for communication networks. So really, what it is you're taking a scenario, but the matrices gives it a digital print, labeling to it, which allows things to go into computers and stuff, which is generally. So let's have a look. So we're going to be looking at networks, and we do networks later on in the year. So important to have. We'll have a look at this again, but we're just using a little bit of a basic thing at the moment. So a network is a set of objects that are connected together. It doesn't have to be an object. It can be like a scenario. And what we have is, and how they are connected. So you'll see these lines. So you see down here in our diagram, we have like A, and then there's a line between A and B. So A and B, whatever they are, in this case, they're talking about their towns, but they could be something else. It could be like a job that's being done. So it could be like you're on a site, a building site, and that A is all the electrical lighting that's getting done, and B could be another job that's getting done, say like the carpet's getting laid, and things like that. So it doesn't have to actually be an object, but let's have a look. So you can have a network, and it shows you how they're connected with these lines. Okay, so down from below, we've got an example of it, which includes a town which may be connected by roads. So we've got a town, and we've got roads in between these. They can also be people. So the A, B, and C could have been a person, and somehow they're connected through, so say A and B was a person, they have one connection that gets between the two of them. But if you have B and C, there may be two connections, so things like that. All right, so it's important to know that the dots, or in this case, the towns, they are called their vertices. Okay, and the lines, which we might just highlight for you. So the lines here, so you can see, they're called edges. So they're called edges. Okay, so there we go. So what we're going to do is we're going to represent this matrix this network into a matrix form. So what you do is, when you have, it's called a communication matrix. How are they connecting with each other? Okay. So when you have a communication network, what you're actually doing, they'll be square networks. So let's just write, square matrices. So let's just write that they're square matrices. And you're going to go see, so if we go to set this little network up, so this is a network diagram. Let's just pop that above that, so we're a bit clear that that's a network diagram. If we go to write up, we're going to call this a communication matrix for it. So if we go to do that, it's going to be a square. So what you do is you have a square, and it's going to be as big as the number of vertices you've got. So because I've got A, B, and C, and then I'll have A, B, and C, okay? So it's this one, this matrix is going to be, if you look at it, is a 3 by 3, okay? Because I had 3 vertices there. And what we're going to do is, how many connections between between them is what we're going to put is the number in there. So if you look at A, is there any edge or edge that goes from A back to A? Is there a looping one? No. So when we see that, we just say 0. So just in case, so if you did, you would have it would look like that, yeah? It just goes to itself. So there's none there. So what about if we go between A and B? How many? Is there a path between A and B? And there's one of them. So we'll do that. Now, between A and C, there's no connection. And then you just can go through the same thing. So between B and A, there was 1. and between B and B, there's no looping in that one. And between B and C, there's actually 2. So once again, between C and A, there's 0. Between B and C, there is 2. And C is 0. Okay? So there I'm setting up a communication matrix there. Okay, so using a matrix to represent connections. So the network diagram on the right, or down below, I should say. So we're just going to write below, sorry. Shows the road connections between 4 towns, so A, B, and C. Actually, we didn't answer this question up here, so we'll go over that. So up here it says, what information is given by the sum of the elements in column B? So what does that, if I add those numbers up, so if I add 1 plus 0 plus 2, so it equals 3, but they're saying what information does that tell me? What is that? There's 3 what? There's 3 roads going into town B. Would you agree? Or coming out of town B? So that's what we'll say. So we'll say that equals 3 roads. We'll say coming out of town B. Okay? So there so see here we got 1, 2, 3 roads. So that's what that one is. Okay, sorry, going back down to here. So they want us to set it up. So for A, they want us to set it up in a matrix form. So what would the order of this matrix be? It's going to be a square. And what will it be? A 4 by 4. Good, because we're going to have A, B, C, D. Now, it's important that the order you have across the top, in alphabetic order, it's pretty easy, but sometimes they give in other names. So if I have A, B, C, D across like that, I've got to do A, B, C, D the same way, downwards, okay? So let's have a look. So we go between A and A. Is there any looping ones? No. Between A and B, there's 1. A and C, none, and A and D, 1. Okay, and then we just keep going. B and A, there's 1. There's no loops. So if you see no loops, we could actually put zeros on the leading diagonal. So that means, because we know there's no loopings, I can quickly see there's no road that just goes back to the same town. So, and then I'll keep finishing. I'm up to B. Between C and B was 1, and between B and D there is also 1. C and A there isn't, B and C 1, and C and D there isn't, and A and D there is 1, A and B there's 1, and there's none like that. So there's our matrix set up, and then we've got what information does the so the sum of the elements in D. So 2, and what does that mean?
There's 2 roads coming out of that.
Yep, good. There's 2 roads. So this equaled 2, and there's 2 roads coming out of town D. Okay, so we'll just pop that. So often they'll ask you to interpret what's the information telling you. So we've done that there. All right, so communication matrices, more importantly, show the links between people. So can I communicate with that person? But we shouldn't probably generally just say it's people. It can be machinery, and that's probably more commonly what it is. So that machine in, say, a big production line, so say in a car manufacturing, that machine can talk to that machine, but not to that one. So, so we need to know how it's connected, okay? So, but most of the time in your bit and when you're learning, we talk about people and who can talk to who or whatever. So we've got a communication network diagram that shows the communication links between people. So you can see here, we've got A, B, we've got 4 people. So who can A talk to if I looked at that? Yeah, good. Who can D talk to? Yeah, so that's what we're talking about. Now, what we call the first, so one-step communication is what we talk about direct communication. So say I was, sending a message straight to Sebastian. So I've sent that message straight to him. That is a direct communication. If he then sends the message over to Henry, that would have been done between me and Henry was done in 2 steps. So that's called 2-step communication. Does that make sense? Yeah. So when I directly talk, what we call that is 1 step. And this diagram here, the network diagram, shows the 1-step communication, like directly. The arrow is showing the 1 step, okay? So a line between 2 people in a diagram indicates there's direct communication link, and this is represented by a 1 in the thing. So you can see down here they've set up this is just pop above this. This is 1-step communication matrix. So it's showing, if I was just given this and not the diagram, I could see that, all right, I look across and I see D can directly talk to B and C. That's what you told me. So I know that. Now, when we do 2 steps, and what we often call this, you'll see them, they label this one with a capital C. So we call the 1-step communication. We like to, so we don't have to write it out all the time. We just often give it a capital C. So then we can represent 2-step communication between with this C matrix. It's what it is the C matrix squared. So if I took this matrix up here, this one here, and I squared it, I will end up with this matrix down below, this one down here, okay? So what this shows us, so what I'm going to, because we really need to understand what it is. So you could get it by just getting the first 1 step and squaring it, but you need to sort of understand. So if I'm going to pick out a number, and I'm going to pick out here, this 2. Okay, so you can see this 2 is between B and C. So what that 2 indicates, so this 2 equals that there is 2 options of 2 steps. So 2 options, that's what the 2, of 2-step communication. So what we're going to do is we'll go back and have a look at that diagram, and what it means that there's 2 options from B to get to C via 2 steps. Now, here's one way. Wouldn't that be 1, 2? If we went to B, to D, to C, can you see that's one option? Yeah? There's the one option. And we can do another way. It could have gone this way, couldn't it? I'll do it in another color so you can see. So my other option could have been like that, where I've gone B to A to C. So there you go. There's the second option. So that is why that 2-step communication has the 2 there. That's why that's a 2, because there's 2 options. So you could get asked, what are they? And then you go in and you tell me. If there was 3 there might have been another way for it to go, but there wasn't. All right.